Hello everyone, this video is regarding JEE Advanced past year questions on the chapter Quadratic Equations and Inequalities Part 5. So the first question for this video: if S is a set of real numbers x such that 2x minus 1 by 2x cube plus 3x square plus x is positive, then S contains which of the following options are correct? So if you consider f of x is equal to x minus alpha 1. I am just assuming one function x minus alpha 1, x minus alpha 2, x minus alpha 3, and so on, x minus alpha n. There, if you see this, alpha 1, alpha 2, alpha 3, and so on are the roots of the quadratic equation on the function f of x, which will lie on the number line alpha in the increasing order. So if you consider f of x is nothing but 2x minus 1 by 2x cube plus 3x square plus x. If you consider 2x minus 1 divided by x into x plus 1 into 2x plus 1. So if you can write this in a number line, what you'll get: minus 1, minus half, 0, and half. This is until minus infinity, this is infinity. So for f of x is greater than 0, means you should substitute a value before minus 1. So you will have a positive here, you have negative. If you substitute these values here, you will have like this: minus, positive, negative, positive, negative, and positive. So for f of x is greater than 0 implies all the positive values you should write. What are those values? Minus 1, minus infinity, minus 1 union, minus half, 0, union, half, comma, infinity. So the options, the key options on this means answers for this question is option A and option D. Moving on to the next question: if a, b, c are distinct positive numbers, then the expression b plus c minus a into c plus a minus b into a plus b minus c minus a minus abc is. Which of the following options are correct? So given that a, b, c are distinct positive integers, the expression, you write the expression which is a b plus c minus a into c plus a minus b into a plus b minus c minus abc. As this expression is symmetric in ABC, we can directly say it as a is less than b is less than c. C minus a is equal to positive, c minus b is equal to positive. So b plus c minus a is positive, c plus a minus b is positive. So but a plus b minus c may be positive or may be negative. So if we consider case 1, if a plus b minus c is positive, then we can say that a, b, c are such that sum of any two numbers is greater than the third. So x is equal to a plus b minus c, y is equal to b plus c minus a, z is equal to b a c plus a minus b. So then x, y, z are all positive. So a is equal to x plus z by 2, b is equal to y plus x by 2, c is equal to z plus y by 2. So if you consider, we know that am is greater than or equal to gm. So if you write that am is greater than gm for distinct real numbers, so x plus y by 2 is greater than root of xy, y plus z is by 2 is greater than root of yz, z plus x by 2 is greater than root of zx. So if you solve this, what you'll get? You'll get the same value, b plus c minus a into c plus a minus b plus into c plus a minus b minus abc. This case, first case, it will be less than 0. And if you consider case 2, also you will get the negative. So in both the cases you will get the value negative. So the answer for this question is, negative. Moving on to the next question: if a, b, c, d and p are distinct real numbers such that a square plus b square plus c square into p square minus 2 into ab plus bc plus cd into p is plus b square plus c square plus d square is less than or equal to 0, then a comma b comma c comma d are in. Which of the following options are correct? So a square plus b square plus c square into p square minus 2 into ab plus bc plus ca into p plus b square plus c square plus d square less than or equal to 0. So if you substitute a square p square plus b square p square plus c square q square c square p square minus 2ab p plus 2bc p plus 2cd p plus b square plus c square plus d square is less than or equal to 0. So if you further simplify, what you'll get? ap minus b whole square plus bp minus c whole square plus cp minus d whole square is equal to 0, which is only possible if AP minus B is equal to 0, comma BP minus C is equal to 0, comma CP minus D is equal to 0. So B by A is equal to P, C by B is equal to P, D by C is equal to P, which implies B by A is equal to B by C by B is equal to D by C, which is equal to P. So A comma B comma C comma D are in GP. So the answer for this question is they are in GP. Moving on to the next question. The equation x power 3 by 4 log x base 2 whole square plus log x base 2 minus pi by 4 is equal to root 2 has, which are the following options are correct? So if you consider this x power 3 by 4 log x base 2 whole square minus plus log x base 2 minus 5 by 4 is equal to root 2. For x greater than 2, you can take log on both sides, you will get 3 by 4 log x base 2 whole square minus log x base 2 minus 5 by 4, which is equal to log root 2. So if you consider, this is nothing but half into log 2 base x. So let us assume that log x base 2 is equal to y. Then we get, if we consider log x base 2 is equal to y, then we get 3 by 4 y square plus y minus 5 by 4 is equal to 1 by 2y. So 3y cube minus 3y cube plus 4y square minus 5y minus 2 is equal to 0. Further simplifying, what you will get? Y minus 1 into y plus 2 into 3y plus 1 is equal to 0, implies y is equal to 1 comma minus 2 comma 1 comma minus 2 comma minus 1 by 3. So log x base 2 is equal to 1 comma minus 2 comma minus 1 by 3, implies x is equal to 2 comma 2 power minus 2 comma 2 power minus 1 by 3. So x is equal to 2 comma 1 by 4 comma 1 by 2 power 1 by 3. So the answers for this question are, there are at least exactly one irrational, exactly 3 solutions, at least one real solution. So the answer is A, B, C. Moving on to the next question. The product of n positive numbers is unity, then their sum is. So they gave x1 and so on, xn, and let us assume this to be n positive numbers. According to the question, x1, x2 and so on, xn is equal to 1. So further simplifying, what you will get? We know that am is greater than or equal to gm. So if you write that x1 plus x2 plus and so on plus xn divided by n greater than or equal to nth root of x1 and so on xn. So x1 plus x2 plus x3 and so on xn divided by n is greater than or equal to 1. So x1 plus x2 plus and so on xn is greater than or equal to n. So the answer for this question is, this value is always greater than or equal to n, which means it is never less than n. Moving on to the next question. The number of divisors that form 4n plus 2 of the integer of integer 240 is. So we have 240 is nothing but 2 power 4 into 3 into 5. So the divisors of 240 are just for 1 comma 2 4 comma 8 16 3 comma 6 12 comma 24 48 5 comma 10 20 comma 40 80 15 comma 30 60 comma 120 240. So out of this, the divisors which form 4n plus 2 are 2 comma 6 comma 10 comma 30, which will form the 4n plus 2 value. So the number of divisors which form 4n plus 2 is nothing but 4. So the answer for this question is option A. Moving on to the next question. If 3 power x is equal to 4 power x minus 1, which implies x log 3 is equal to 2 into x minus 1 log 2. So x is equal to 2 log 2 by 2 log 2 minus log 3, which implies x is equal to 2 log 2 base 3 divided by 2 log 2 base 3 minus 1, which is equal to 2 by 2 minus log 3 base 2. Also x is equal to 1 by 1 minus half log 3 base 2, which is equal to 1 by 1 minus log 3 base 4. So the answer for this question is option A, option B and option C. Moving on to the next question. Let S be a set of all non-zero real numbers alpha such that quadratic equation alpha x square minus all x plus alpha is equal to 0 has two distinct real roots x1, x2, x1 and x2 satisfying the inequality mod x1 minus mod x2 mod of x minus x1 minus x2 is less than 1. Which of the following intervals are a set of S? So answer, how will you proceed with this sum? Initially they gave a alpha x square minus x plus alpha is equal to 0 has distinct real roots, implies d greater than 0, implies 1 minus 4 alpha square is greater than 0, which will give me alpha belongs to minus half comma half. We know that mod x minus x1 minus x2 is less than 1, right? Less than 1. So x1 minus x2 whole square is less than 1, implies x1 minus x2 whole square, x1 plus x2 whole square minus 4 x1 x2 is less than 1. So 1 by alpha square minus 4 is less than 1. So 1 by alpha square is less than 5, implies alpha square is greater than 1 by 5. So alpha belongs to minus infinity comma minus 1 by root 5 union 1 by root 5 comma infinity. And if you consider this is first, this is second, if you combine those both, the answer for this question is option A and option D. I am combining this to be 1 and this to be 2. If you combine these both and simplify, you will see that option A and option D are correct. Moving on to the next question. Let xyz be the integer coordinates satisfying the system of homogeneous equation 3x minus y minus z is equal to 0, then comma minus 3x plus z is equal to 0, and 3x minus 3x plus 2y plus z is equal to 0, then number of points such that x square plus y square plus z square is less than or equal to 100 is. So until now we did the multiple answers with more than correct answer. In this chapter we don't have any previous advanced questions on matrix matching, so we are going into the integer type questions. This is an integer type question. They give 3x minus y minus z is equal to 0, minus 3x plus x z is equal to 0, minus 3x plus 2y plus z is equal to 0. Then number of the points is that x square plus y square plus z square is less than or equal to 100 is. So let us assume x is equal to p, where p is an integer, then y is equal to 0 and z is equal to 3p. So but they give x square plus y square plus z square is less than or equal to 100. So if you substitute that, p square plus 9p square is less than or equal to 100. So p square is less than or equal to 10, implies p is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3. So the number of values of such type is answer 7. So 7 answers are there. So answer for this question is 7. Moving on to the next question. The smallest value of k for which the both roots of the quadratic equation are real and distinct. It's for a quadratic equation real and distinct in the sense discriminant value is greater than 0. So 8k square minus 4 into 16 into k square minus k plus 1 is greater than 0. So if you simplify this, k value is nothing but greater than 1. So if you simplify this, k value is greater than 1. Both roots are greater than or equal to 8. So alpha plus beta value is greater than 8 and f of 4 is greater than or equal to 0, implies k is greater than 1. So 16 minus 32k plus 16 into k square minus k plus 1 is greater than or equal to 0. So k square minus 3k plus 2 is greater than or equal to 0, implies k minus 1 into k minus 2 is greater than or equal to 0. So k belongs to minus infinity comma 1 union 2 to infinity. So combining these two equations, k value must be greater than or equal to 2. So the least value of this is 2. So answer for this question is 2. Moving on to the next question. The minimum value of sum of real numbers a power minus 5, a power minus 4, 3a power minus 3, 1, a power 8 and a power 10, where a is greater than 0 is. So for this question we can use am is greater than or equal to gm property. What you will get? 1 by a power 5 plus 1 by a power 4 plus 3 by a cube, which can be written as 1 by a cube plus 1 by a cube plus 1 by a cube plus 1 plus a power 8 plus a power 10 divided by 8 greater than or equal to 1 by a power 5 into 1 by a power 4 into 1 by a cube into 1 by a cube into 1 by a cube into 1 into a power 8 into a power 10 whole power 1 by 8, which implies 1 by a power 5 plus 1 by a power 4 plus 3 by a power 3 plus 1 plus a power 8 plus a power 10 greater than or equal to 8 into this value is nothing but 1 power 1 by 8. So the answer for this question is 8. Moving on to the next question. The number of distinct real roots of x power 4 minus 4x cube plus 12x square plus x minus 1 is. So x power 4 minus 4x cube plus 12x square plus minus 1 plus x minus 1, this can be simplified as x power 4 minus 4x cube plus 6x square minus 4x plus 6x square plus 5x minus 2. So this part can be written as x minus 1 whole power 4 plus 6x square plus 5x minus 2 is equal to 0. If you further simplify this, what you will get, x minus 1 whole power 4 is equal to minus 6x square minus 5x minus 2. To solve this polynomial, it is equivalent to the find the intersection point between y is equal to x minus 1 whole power 4 and this y is equal to minus 6x square minus 5x plus 2 is equal to 0. So if you consider this as y1 and y2, we should find the point of intersection of y1 and y2. So if you simplify, do that there, x plus 5 by 12 whole square is equal to minus 1 by 6 into y minus 73 by 24. So if you consider this, these two graphs will touch exactly at 2 points because it is a parabola. Two parabolas touch at exactly 2 points. So the answer for this question is 2. With this we conclude the chapter Quadratic Equations and Inequations, and we'll get back to you in the next chapter. Thank you.